Now we are going to begin the quick exploration of the 13 components of mathematics. Earlier, I tried to relate them to daily usage. So the earlier section was comparatively much more fun. This section is supposed to be boring. I am trying to squeeze 12 years of mathematical equations in a dozen pages or a few thousand words. Why? As I told you earlier, the way we have been taught mathematics has prevented us from loving the subject and built in us a fear of it because it seems so vast and never ending. However, it could be nothing more wrong than to believe in the endlessness of mathematics. No, mathematics is limited and it consists of basic construction materials. I will again go into my yellow brain mode of explanation, if you will forgive me for a few sentences. No matter how big the building is, or how complex it is, or how marvelous it is, this structure is nothing more than the various materials it is made of, which are common for all of these buildings. We need some bricks, some iron rods, some cement, a bit of water, sand, some rock pebbles. Then there'll be some few other items. If the engineer or the laborer knows how to work with these few materials, they can build any monuments, be it the cathedral of Notre Dame or the Taj Mahal or the Empire State Building. Similarly, in mathematics, there are limited components which, if you can master, can help you progress easily into a higher level of mathematics for engineering, physics, economics, software, or pure mathematics. Also, the same limited components can help us build a small house for a family of three. Similarly, in mathematics, these limited components can help us get through your shopping trip and prevent yourself from being cheated. Among those 13 components, the first one are numbers. If you are reading this book, you don't even need to read this section, but it might help your students because it will help them see the various manifestation of numbers throughout their 12 years of education. When we talk about numbers, we have to develop different ways to classify them. It's like saying you as a person can be classified in terms of gender, age, occupation, nationality, and so on. Each classification has its purpose. Now, numbers can be classified in terms of different properties, so they give rise to various types, like some numbers can be called natural numbers, some can be called integers, some will be called rational numbers, and so on. Then for higher mathematics, there will be a type of number called the complex numbers. However, for the layman, the two types of numbers that we are most used to hearing are even numbers and odd numbers, right? Then definition of numbers progressively increase from ones to tens to hundreds, thousands, millions, billions, trillions, and so on. Also, there is a concept called absolute value, where any negative term has the absolute value being positive. Then we have reciprocal numbers. Again, this particular section just serves for you to try to recall the various terms that you might have heard in school and just tick it in your head. Math is not endless. That's the main point I want to put here. Next, we have use those terms so many times, like equal. It's almost self understood to us that if A is equal to B, then obviously B is equal to A. That's the symmetric property of equal sign. However, we have learned it in school. But if you missed that class on that particular day, not knowing this particular property might spell trouble and difficulties later on. Similarly, the translative property of the equal sign is if A is equal to B, then and B is equal to C, then obviously A is equal to C. So these are all the things we should have learned in school. And if we haven't, then you should go back, watch a YouTube video about it, and secretly relearn it. Similarly, the property of inequality is that if A is greater than B, then A plus C is also greater than B plus C. Whenever there are many numbers to calculate, then there's a universal standard in which it is told to us which operations to do first, and that's called PEMDAS and BODMAS. Basically, it tells us that you have to calculate the numbers that are first within the parentheses, followed by the brackets, and finally the braces. Also, it tells us that you first calculate whatever contains exponentials and powers, then you calculate whatever sets of numbers use multiplication and division, and finally you do the addition and subtraction. If we did not have such a rule, then whenever we have multiple numbers to calculate, different people would come to different answers. Whenever we are doing the operations of plus and minus, the day we decided not to use our fingers, we used our memory to do calculations, as well as using the various rules. Many of us have stopped using the manual approach for adding and subtracting, and instead use the calculator. But still, it's important for us to remember the properties, like the cumulative properties, which says that it doesn't matter in which order you add the numbers, the result will be the same. The associative property tells us that if there are various numbers to add up, then it doesn't matter where we put the parentheses. And similarly, there are the identity property and inverse properties, and maybe a few others, but they are all limited. When it comes to multiplication, we know that multiplying minus number with a positive number gives a negative product. These are some of the rules that we have been following since childhood, even though we don't remember it fully. Then when we multiply two negatives, then it becomes positive. Dividing any number by zero is undefined or doesn't give any results. Like for addition and subtraction, there is also cumulative, associative, identity, inverse property for multiplication and division. That's all. However, unique to multiplication and division, there is something called the distributive property, which is very useful. You can look in the diagram for more details. Basically, what it's saying is if a number multiplies two numbers that are added within a bracket, then that number outside the bracket multiplies both the numbers inside. Yes, it's easier to look in the diagram. When we come to fractions, then we need to learn some definitions. The number above the line is called the numerator, and the one below the line is called the denominator. If the numerator is greater than the denominator, then it's called an improper fraction. If, on the other hand, the numerator is less than the denominator, then it's called the proper fraction. Sometimes fractions appear as mixed numbers, that is, one part will be an integer and the other will be a fraction. Then we can write ratios using various notations. We can use either the two dots or the line between the two numbers. Then we can simply define percentage in terms of fractions, like 50% is equal to 0.5. Then we have to know that fractions are also equivalent, saying one part of 2 is the same as 2 parts of 4. Next, when it comes to fractions, we just need to understand and memorize the rules because they serve us once and for all. The first rule is the simplification of fractions. Here we try to divide the numerator and denominator with one another until the numerator is either 1 or any number we cannot further divide the denominator with. Then the most important thing about fractions is adding two fractions. The rule is to find the common denominator between the two or more fractions and then use the rule for the operations of fractions. If you missed that class, then anything you study with regards to mathematics or anything that concerns mathematics will be a nightmare. So please, if you do not understand what I just said, silently go on YouTube and get a tutorial if you are too shy to actually go back to school. And then there is a rule for converting percentage to decimal and then to fractions and vice versa. You should easily be able to do that. Then there is the percentage increase decrease rule. For example, 10% increase is 10 parts of 100, but a 10% increase on 2000 is 200. So up till now, we have dealt with arithmetics below class 7. If any of the things that I said don't sound familiar to you, remember that you're in trouble and that is why you are not able to love mathematics. You just need to know at least all the rules, definitions, properties that I have mentioned for the different components here. You should be able to practice basic problems up till class 7 using these 5 components of mathematics. If you want to make a decent living and not become poor or not to be swindled, then these 5 components of mathematics will definitely help you. Even if you are not familiar with the remaining 8 components that I'm going to talk about, you could still do very well in subjects like management, where there is some level of mathematics required. So I repeat, take it as a crash course, and if you are a teacher or a counselor or a owner of a college, then make sure that your students go through this section, read it loud to them, and if they look puzzled, then take it as a red flag. That's where their education in math stopped. Without this, higher mathematics is not possible. Then, with sheer luck and fake it till you make it personality, these students will easily go to higher grades. However, they are handicapped because they lack the basic components required to understand, learn, and master mathematics after grade 8 up to 12. Also, that is why we have so many people who are financially dumb. They missed the mastery of those 5 basic mathematical components.